What's up guys, welcome back to another video. So today we're going to be talking about centrifugal acceleration. So without further ado, let's jump right into it. One of you guys asked me to make a video explaining about centrifugal acceleration. So what is centrifugal acceleration in the first place? Well, centrifugal acceleration is the acceleration that is exerted on some mass that is moving in a circular track with some radius r, and the speed of the if the speed of that particular mass is the same, and it's moving in a circular track, the magnitude of the acceleration is equal to v squared over r. And the reason why the acceleration is a constant is because the rate of change in the direction is always the same as a circle is symmetrical in all ways, and the direction of the acceleration is pointed towards the center of the particular circular track that the mass is revolving around. So now let's see why this is true. Why does this relationship holds up? So what is acceleration? Acceleration is the derivative of velocity with respect to time, dv by dt. And what is dv? dv is the difference between the final velocity vector after the time period dt minus the initial velocity vector, or else the velocity vector at t. Well, if we write it down, we have to take the limit as delta t approaches 0. Well, v of t plus delta t is the final vector, that minus v of t is the initial vector, that over delta t is the acceleration. And this, if we assume that this is the initial velocity vector after time period dt, our mass is going to move by some small amount, by a small angle d theta, and that small angle is equal to the angular speed times the time. Angular speed, omega stands for the angular speed, and this angle is omega times t. And this is how the velocity vector is going to look like. It's going to be pointing in that direction, perpendicular to this radii. And if you put these two vectors together to get the difference between them, we are going to get an isosceles triangle. Remember, when we are getting the difference between two vectors, we do that by combining the heads of the vectors together. So in order to solve for this length, we need to know this angle. So let's find that out. So we are going to take this vector over here and expand out a line like that. What we're going to do is we are going to find out the angle between these two, and this is omega times delta t, and this is 90 minus omega times delta t, and this is a 90-degree angle because this is a perpendicular, the tangent to the circle, and this is the tangent point. And when we construct the radii to the tangent point, the angle that is made between the tangent and the radii is 90 degrees. And this is 90 minus d theta omega times delta t. And in order for the sum of all three of these angles to be 180, this must equal d theta. So that means that this angle over here is d theta. So what is d theta? D theta is omega times delta t. And now we know this angle, and now we can simply work out this without much trouble. So we are going to split this isosceles triangle into two right angle triangles like that. This is V and this is omega times delta t over 2, because the angle is going to get divided into two equal angles, and this is sine of this angle times V, sine of omega times delta t over 2 times V. And remember, there are two such lengths, so we multiply that by 2, and that's the difference between these two vectors. Yeah, we're going to plug this value over here. There we go. So now we need to figure out this limit. So we can't just straight away plug in 0, because we're going to get 0 as the denominator of this number, and that's undefined. So we have to use the L'Hospital's rule. So we are going to differentiate the top and the bottom of this fraction with respect to the limiting variable, which is delta t. So if we differentiate delta t with respect to delta t, we are going to get 1, and this just cancel out, it just disappears. And now we are going to get the derivative of this. The constants come along, and the derivative of this is cos of this angle times the derivative of the inside, which is omega over 2. According to the chain rule, we must multiply the derivative of the inside. So the derivative of the inside is omega over 2, because we are differentiating with respect to delta t. And now some cancellations happen. The 2's cancel out. And what's omega? Omega is V over R. And now we can plug in 0 without much trouble. We are going to get an undefined form. So if you plug in 0, substitute in 0 as delta t, for delta t, this whole thing is going to turn into 0. 0 times anything is 0. So cos of 0 is 1, so that also disappears. Cos of 0 is just 1, so this just cancel out, and we get v times v over r, and that's the same as v squared over r. And that's the proof of this relationship, v squared over r equals a. And I hope you enjoyed this video. Please make sure to hit the thumbs up button and subscribe to my channel. See you in the next video.